Okay, good afternoon, ladies and gentlemen. This is take two, so I've already got some stuff circled on here. All right, our objective for today is that students will be able to compare exponential relationships with different growth factors. So these are some new vocabulary words that we're going to be seeing a lot this upcoming unit. We're going to talk about them today, try to use them in context to figure out what they mean. Okay, so just talking about what exponential growth means. In the last two investigations that we saw, where we were talking about stacking pennies on top of a chessboard and we were talking about cutting paper, both of those were examples of what we call exponential growth. Now, exponential growth is when numbers grow by multiplying. So remember, in both of those cases, we saw that the amount of pennies, the amount of paper slips was doubling as we went down the columns in our table, right? Now, the number that you're actually using to multiply by, in that case, 2 for those two examples, is something that's referred to as the growth factor, okay? So just let's really quickly revisit the example that we saw yesterday, right? We were talking about a peasant. They asked for the king to put 1 penny on the first square of the chessboard, 2 pennies on the next, 4, 8, and the amount of pennies doubled every time we went up, right? So because it's doubling, we're multiplying by 2 every time. That's not a linear relationship. Remember, a linear relationship is when you add going from place to place. When you multiply from place to place, again, that's going to be something called an exponential relationship. And that's what we're studying this unit, things that grow at an exponential rate. So just to remind yourself of what we saw yesterday, remember we had 1 penny on the first square. We doubled that to 2. Then we doubled it to 4. We doubled it to 8, 16, 32, 64, 128, 256, 512. So what you can see is that exponential growth grows extremely fast, right? At the beginning, we're starting, right? I only added 1. Then we added 2. Then we added 4. Then we added from here to here, 8. So we're not adding a lot at the beginning, but by the time we get from here to here, we added 256. So exponential growth grows at a very fast rate, right? Much faster than linear growth. And that's what we're going to be exploring this unit. So just to remind you of the equation that we found yesterday that represents this specific relationship, it looks like this. Y equals 2 raised to the x minus 1. And just to show you how that works, right? For example, let's say I think about when I have 6 squares. If I substitute that 6 into here, I get y equals 2 raised to the 6 minus 1. 6 minus 1 is just 5, so that says y equals 2 to the 5th power. 2 to the 5th power is equal to 32, which is what we have here. Okay? So this equation here models this exponential relationship, and this is what our exponential equations are going to end up looking like for the rest of this unit, right? Now, we're not focusing on the equation too much today, so don't worry about it. We just really want to focus today on thinking about the growth factor and thinking about exponential growth in general, okay? Remember, this here was the peasant's plan, and the peasant's plan was actually a lot of money. I'm not sure if you got to the last question, but it ended up being kind of like an unfathomable amount of money that the king was going to give away, right? So the queen found out about this, and she said to him that he's promised the peasant way too much money. We need to figure out a different award to give the peasant, okay? So what we're going to look at today is we're going to look at a couple of other options that they decided to try and convince the peasant to take, okay? So first one. Plan 2, the king's new plan. After the king is thinking, he says, okay, so here's my plan, right? We're gonna start with a board that's only 16 squares, right? So it's much smaller than a standard chessboard. The chessboard that we saw originally was 64 squares, right? So we cut down the size of that board, right? Now he's saying, okay, first square, we're gonna put 1 penny. On the first, we place 1 penny on the first square, 3 pennies on the second square. And then he draws a graph to show how many pennies will be on the next, okay? So square 1, 1 penny. We know that this one here, it says is 3 pennies. And now this graph here tells us how many pennies are going to be on the other squares. So this tells us how many are on square 3, square 4, square 5, right? You're gonna have to use this graph later to fill out a table. Now, the queen also comes up with her own plan, right? So the queen has a different size chessboard. Remember, this chessboard here had 16 squares. The queen's chessboard now has 12 squares. So we have different sizes of chessboards and they're growing at different rates. Now, the queen says she's gonna place 1 penny on the first square. So 1 penny here. And then she's gonna use the equation P, which means pennies, is equal to 4 times 4 raised to the n minus 1 power. So to figure out this here, this is square number 1, right? The way that we would do that is this is square number 1 here. This is square number 2. So to figure out why this is 4 here, we would say that the number of pennies is equal to 4. In this case here, n is equal to 2. N equals 2. So I'm replacing the 2 minus 1. 2 minus 1 is just 1, so that's equal to 4 to the first power. If we want to figure out the next square, we'd say this here is the third square, that's n equals 3. So I would say P is equal to 4 to the 3 minus 1 power. 3 minus 1 is equal to 2. All right, so that's what you're going to use later to start trying to fill out your table. All right, now before we start though, you're going to answer 2 questions. The first question says, just simply, how do plan 2 and plan 3 differ from each other? So there are a couple of ways that they differ from each other. I want you to write as many ways as you can think of here. And then just without doing too much math, which of those 2 plans do you think would be better for the kingdom? Plan number 2 or plan number 3, and explain why you think that, okay? That's the first part. Once you're done with that, the next page over here, you're just gonna go ahead and list out the number of pennies that are on each of the squares going all the way up to the 10th square. So I started to help you out with the table here. You just need to fill in the rest of the blanks. So just a visual reminder, plan number 1, that was the peasant's plan. I actually gave you the numbers and you found those numbers yesterday. So those numbers are already for us over here. Next one, to figure out plan number 2, the king's plan. That's gonna come from this one up here, right? Look at this graph here. So figure out what number is this over here? How many pennies do I have at 3? How many do I have at 4? How many do I have at 5? And then you're gonna continue that pattern going down. Similarly, looking over here at the queen's plan, we see that we had 1 penny over here. We have 4 pennies over here on square number 2, and square number 3 ends up being 16 pennies, okay? So again, 1, 4, 16, and you're gonna start to notice a pattern with each of these here, okay? Now, once we have that table done, right, you're gonna wanna pause the video, get your table done first before going on, right? What I say next is do the patterns of plan 2 and plan 3. So this is plan 2, this is plan 3. When I say the patterns, look at how these numbers are changing, right? Do they represent exponential growth, okay? So exponential is actually our Zoom password for today. Lowercase, exponential. Again, that's our Zoom password. So is this exponential growth? Again, think back to that very first page. We said exponential growth is a pattern that involves multiplying by a fixed number. So when you're multiplying by the same number over and over again, it is exponential growth. So based on what we see here, is plan 2 exponential growth? I want you to write out a sentence. There's a sentence starter here that you can use to help start you out, and then explain why you know it's exponential, right? I am also asking you, if it is exponential, to just give me the growth factor. So the growth factor is the number that you are multiplying by in an exponential relationship. So looking at this first one here, right? I already told you it's exponential for plan number 1. So I know it's exponential because as I go down this table from here to here, I multiply by 2. From here to here, I multiply by 2. From here to here, right? I'm always multiplying by 2. So I know that this relationship is exponential, and I know that this table here, plan number 1, has a growth factor of 2, because that is the number that we are constantly multiplying by. So 2 is the growth factor for number 1, right? So again, very simple sentences. You're doing the same thing for plan number 2, and then also for plan number 3 on the next page. All right, so this part over here I'm going to help you out with because, again, the equations are going to be a little bit harder at the beginning, but if you want to attempt this part for yourself first, pause the video now, try to get that done. Okay, so just to review, right, what we want to figure out is what the equations are. We know I gave you the equation for plan number 1 was p equals 2 raised to the n minus 1 power. So to try to find an equation for plan number 2 and plan number 3, we want to think about how are they changing, right? Now, if you looked at your tables, you should have seen that they all had growth factors of the number that we were multiplying by, right? So this one over here had a growth factor of 3 because we keep multiplying by 3. This one over here has a growth factor of 4 if you work out the exponents because you keep multiplying by 4. This over here had a growth factor of 2 because we kept multiplying by 2. So if you think about it and you can try to play around with it, the equations are actually extremely simple. All I need to do is change the 2 here to a 3, and again, change that 2 to a 4 here. So those are your 2 equations, 3 to the n minus 1, 4 to the n minus 1. So now this here's how does the growth factor you discussed in part 1 and question 3 show up in the equations for each of the plans, okay? So this one is pretty easy. I just told you that the growth factors are 2, 3, and 4. We just need to know how to describe these numbers. So when I'm talking about an exponential term, I call it this number here, the little number, the exponent, this number here, the base. So I could say that the growth factor shows up as the base of the exponential term. Now, when I say exponential term, I'm talking about the thing that has an exponent. Again, if I had something like, say, 3 to the 5th power, we call the 3 in this case the base. Sorry, you can't see that. And we call the 5 the exponent. So the growth factor, the thing that we are multiplying by, shows up as the base. Okay? Now, the rest of the packet, you are going to try to do yourself. You're going to look at part 3. For part 3, we're saying that we have an entirely different plan. The king has a financial advisor, and he is giving them a different plan. He's saying, okay, we're still going to use a chessboard that's 64 squares, but what we're going to do instead is we're going to put 20 pennies on the first square, 25 on the second square, 30 on the third, and so on. Each time they're going to keep increasing by 5 pennies per square. So read through that again, try to make sure you understand it. Then you're going to fill out this table here to show how many pennies are on the first 10 squares. Once you do that, just like we did before, does this here represent an exponential growth pattern, right? Based on what we said an exponential relationship looks like. Does this look like it's exponential? Explain why or why not. What I want you to try after that is to see if you can write an equation to represent the relationship. And the final thing that I want you to do, sorry, actually the final 2 things, is to first figure out how many pennies would be on the last square of each of these boards. So plan 1, right? That's going to be square number 64, because I had 64 squares. Plan number 2, how many squares did that have? Plan number 3, how many squares did that have? Plan number 4, how many squares did that have? Use that information along with your equations to figure out the answer to these. And then at the last box here, you're just going to fill out which of these 4 plans is actually the best bet for the kingdom. All right. So we'll have a Zoom session open at 12:30. If you have any questions, bring them there. Just make sure you please watch the video. Start answering the questions before you come. All right. Thanks and good luck.